In this question, we are informed that there are 7 counters, red counters in a bag. So the rest of the counters in the bag are blue. So um, first of all, you can say let the number of blue counters be x. So let the number of blue counters be equal to x. So total number of counters will be equal to x plus 7. All right, and then we are informed that there are more blue counters than red counters. So the number of blue counters are more than red. Okay, um, and then 2 counters are taken at random from the bag. Now this is without replacement. Without replacement. So the probability that there will be one counter of each color is 7 over 15. So I'm going to show this in the tree diagram, and then from the tree diagram we shall be able to analyze this in a better way. So, but it's optional. You can either use a tree diagram or not. But I think for purposes of visualizing, it's better that we use a tree diagram to get a better understanding. So suppose this branch represents red and this is blue. This is the first event. So probability of picking a red counter will be 7 over x over 7 over x plus 7. Now we know that there's 7 red counters. And then the probability of picking a blue will be x over the total number of counters, which is x plus 7. Well, for the second event, again, we can either have a red or a blue counter. Now, the probability of picking a red counter, if the first one was red, will be, now we know that the number of red reduces by 1 because this is without replacement. So the total number of red will now be 6 over the total number would have reduced by 1. So x plus 6. And then the number, if the first one was red, the number of blue will still be um, x. So x over x plus 6. Now, if the first one was blue, the number of blue reduces by 1. So x minus 1 over the total number reduces by 1 as well. So x plus 6. If the first one was blue, the number of red will still be 7 over the total number reduces by 1. So x plus 6. Now, the question here states that the probability that there will be one counter of each color. So basically one counter of each color means either you have red followed by blue or blue followed by red. So those are the probability that some of those probabilities will give us 7 over 15. So here, this branch here, which is the required branch, both of these are required branches. So this is red followed by blue will be equal to now if you're working out probabilities along these two branches, you multiply them, so that will be 7 over x plus 7 multiplied by um, x over x plus 6. And here now remember, here we have the word or, yeah, or this. So this is blue followed by red, which will be x over x plus 7 uh, multiplied by 7 over x plus 6. Okay. Now, obviously, if you work this out, let me just work this out. So this will be equal to 7x over x plus 7 multiplied by x plus 6. and this will be equal to 7x over x plus 7 multiplied by x plus 6. So here we have OR, yeah, OR means you add. So basically we add this. Now if you add this should be equal to 7 over 15 because that's what the probability is that you're given here, 7 over 15. The probability that will be the probability that there will be one counter of each color. So what we're going to do next is basically to add these two together and basically form an equation and solve for x. Okay, so basically the next step will be we know that from here, so we know that 7x over, and by the way, if you add these two because they have the same denominator, we can add the numerators. So we'll have 7x plus 7x over x plus 7 multiplied by x plus 6, and that should be equal to 7 over 15. And we can add the numerators and also multiply out the denominators, just FOIL them. So what we shall end up with will be 14x over x squared plus 7x plus 6x plus 42, 7 over 15, which will be equal to 14x over x squared plus 13x plus 42, and this will be equal to 7 over 15. All right, so at this stage, what we can do is solve this equation, cross multiply. So if you cross multiply, you'll have 14x multiplied by 15 will be equal to 7 into x squared plus 13x plus 42, and this will be 210. X will be equal to 7x squared plus 91x plus 294. Bring everything to one side. So if you take that to that side, you'll have 7x squared, and that will be minus 119x plus 294 is equals to 0. Now at this stage you can simplify our quadratic equation by dividing each side by 7. So we shall end up with x squared minus 17x plus 42 is equals to 0. Now we can factorize this quadratic equation. So to factorize it, you can just draw a factor tree. For example, if you have let's say 42, all right, so running out of space. So 42 divided by 2, 21 divided by 2, 3, 7. And you can see here that we want two numbers which add to negative 17 and multiply to get 42. And the two numbers here, if we combine 2 and 7, the two numbers will be 14, negative 14, and negative 3. Yeah, so these two multiply to give 42, and multiply to give 42 and add to give negative 17. All right, so we can carry on and factorize this equation. So what we shall end up with is x minus 14 multiplied by x minus 3 is equals to 0. So which means x is equals to 14 or x is equals to 3. But now if you go back to this question, it states that there are 7 red counters and the number of blue are greater than red, which means the number of blue should be greater than 7. So which means that blue counters, so blue will be equal to 14. Okay. And the question is asking for the total number of counters. So total number of counters will be equal to 14 plus 7, which is equal to 21. Okay.